Hello and welcome to another video. In this video we're going to be working on minimum number of days to make M bouquets. And this one you're given an integer array bloom date and an integer M and K, and it's the description's kind of annoying, so I'll try to explain it. Basically, the array bloom day is the day that the flower blooms. So all of these are flowers and these are the days that they bloom. So this blooms on day 7, and so on. And you're trying to make M bouquets, and to make a bouquet, it takes K flowers, and they have to be adjacent. And you were asked to return the smallest day that you can pick where you can make this bouquet. So let's go through this. So here, it takes 1 flower to make a bouquet, and you need 3. So you would just pick the 3 flowers that bloom the fastest, so 1, 3, 2, and you get 3. So on day 3, you can have that. So that's what you return. On day 2, you want 3 bouquets, and each bouquet takes 2 flowers, so you need 6 flowers total, so that's already impossible, so you can just return false there. And for the last one, you're trying to make 2 bouquets, each bouquet needs 3 flowers, you're trying to make 2 bouquets, each bouquet needs 3 flowers, I believe, yeah. So one way you could do it is like this, and like this. There's basically no way to make 2 bouquets without including this 12 guy, so you need to return 12. And so there's a couple of things you need to know for this problem. And the first is, let's just say we're given a day, like here, for example. Let's just say we're given like the day we're on, like day 12. And you want to make bouquets somehow. Or let's say we're on day whatever, like day 7 here. And you want to make bouquets of 3 flowers. How do you go about picking your flowers? Like, does it matter if this flower is in the first bouquet, or maybe like I want this to be a bouquet, or like so on? And so it turns out that it doesn't actually matter like which way you make it. You can just be greedy. So what you can do is every flower that blooms, you can just start putting into a bouquet. So if we are on day 7, we're going to include this guy in a bouquet. Like everything we're into, we'll just put into the bouquet. So this guy, and that'll be 1 bouquet. And then for the second one, we will try to put in this one, which we can. Then we try to put in this one, and we can't. And as soon as there's a flower that we can't put in, we have to start over making a new bouquet. So we do these 2, and then we can't. So we can only make 1. So the idea is, given a day and an array, it's pretty easy to figure out how many bouquets we can make. Like we can just, like we basically just be greedy. Like let's say we have some random days like this. 2, 5, 1, 2, 3, 4, 1, 2, let's say. So if our, let's say K here is 2 flowers, and the day we're on is like day 3 or something, 4. Like I said, we can just be greedy, so we can just say like, can we put this into a bouquet? No. Okay, go to the next one. Can we put this in? No. Can we put this in? Yes. Can we put this in? No. So then we're going to start over again. Can we put this in? Can we put this in? Yes. So this is like 1 bouquet. Then this will be another one. Then this will be another one. And there's never going to be a better way of like, let me avoid this guy to make these, or maybe avoid, like you always just want to greedily take the ones you can right away and put them next to each other. So with this example, this is the bouquets you would make. And now we can take this idea combined with looking at our constraints. This is the other thing that you want to look into when you first start doing the problem. So you have 10 to the 5th flowers, and the days is 10 to the 9th. So you can't just like manually try every day, because that would be way too big. Like even if you can get, even if for every day you can get a yes or no and O of 1, that would be too slow, because I think LeetCode fails at like 10 to the 8th or so. So that's kind of like a small hint of where you want to go. But basically, if given a day, you know how many bouquets you can make. We also know that, let's say, for some array on day X, we can do this. That means that for every day greater than X, right? Anything greater than X, so for any Y greater than X, this will also work. But for anything less than X, we don't know. Like it might be possible, it might not, right? Like for this example, on day 12, we can do things. On day 11, we can't. But like, let's say we just happen to try day 15. If on day 15 we can, we might also be able to on day 14, and so on and so on. And so because you know this, then you can just, the other thing is, the other way is, if on day X we can't make the bouquets, then on every Y less than X, we obviously can't as well, right? So like if 7 failed here, then 6 and all those aren't going to work, right? Because as a day increases, you can only make more bouquets. You can't make less. Or sorry, yeah. As the day increases, you make more, but as the day decreases, you can only make less. You can't make more. So if we try day X and we know, like let's just say we try some random day here, like day 15, and this works, then we know that like anything 16 and up, we don't really care about because 15 is going to be better, but we still have to try the days below. And if we try 15 and it doesn't work, then we know that 0 to 15 is no good, and we want to try 16 and up. So this is basically a binary search. So we can just make a function, given a day, how many bouquets can we make? If we can make enough, then we'll try a smaller day, and if we can't make enough, we'll try a bigger day, and then we just get the answer there. And then that would give us a log days times n solution. And log 10 to the 9th, I don't know what it is off the top of my head, but usually log values are pretty small. So when you have, two values that are like 10 to the 5th, 10 to the 6th, whatever, and you log one of them, that will pass. So that's what we're going to do. We're going to try every single day in a log in a binary search, and then we'll just make a function to say how many bouquets can we make given that day. Now that we know, you just take the flowers greedily. And if you didn't know you want to take the flowers greedily, well, how I approach this problem is like I thought of a binary search pretty quickly, and then I was like, okay, well, for a binary search to work, there has to be like a good way of taking the bouquets you can make. Like you probably can't do like a DP or something on the flowers. So I was like, what if I just take the flowers greedily, and everything I take, I just keep trying to combine it to a bouquet? And I couldn't think of a counter example, so that's what I went with, and that turned out to be correct. So that's the thing I'd recommend, is like think like, can I take these things greedily? Can I think of a counter example? Because that's generally how you're going to like disprove what you're doing. And I couldn't think of one there. So that's what we will code. So let's make a function that we will pass in like the number of days we have, and then an m and a k, and it will return if it's possible to get that many bouquets given that number of days. So we'll just say private int is possible or something, or can make bouquets, whatever. And this will take, this should be a Boolean. So this will take the bloom day array, m, k, and the number of days the day we're on. So what we need to do is we'll have like a result for the number of bouquets we made, start off with 0, and current for like the total number of flowers we have, and then every time we reach k flowers, we can make a new bouquet. So that's all we need. So we're going to go through this array. So for int flower in bloom day, if flower is greater than less than or equal to day, that means it bloomed. So we are going to increase our current thing. Otherwise, we are going to reset our current to 0 because we can't use that flower, so we have to start over. And here, if current equals k, then we can make a bouquet. So we'll do this and reset current. And also, if result equals m, that means we've succeeded, we've made enough bouquets, so we can return true here. You could do this here, or you could check at the very end. Either one's fine. I'll just check here. And if we go through this whole thing and we never return true, we were never able to make our bouquets, so we just return false. Okay, so that's done there. Now all we have to do is figure out like what's the what are going to be our bounds for the days. And so that's the other thing. The efficient way to figure out the bounds for the days. So first of all, we can say if m times k is greater than length of bloom day, right? That one example. Then it's not possible to do this because we just don't have enough flowers, right? So if we need 3 bouquets of 30 flowers each and we only have 30 flowers, we can't do that. Now, as far as the bloom days, what we can use is the minimum and maximum of the value in the array, because we know we can't take any flowers unless we take the minimum value in the array, right? Because nothing's going to be bloomed. And if we just take the biggest value in the array of bloom day, then that every flower we bloom. So we can use those. So we can just record those. We can say like int left equals, we'll just, we're going to try to minimize this. So we could say like integer, I think this is like max value or something. Let's turn on this guy. And the other way. Okay. So for flower in bloom day. Now you can just initialize them to like 1 and 10 to the 9th. That would also work. So this will be left equals minimum of left and flower, and right equals maximum of right and flower. I guess technically we don't even need this. I think this will be like negative. We can just make it 0. That'll be fine. Okay. So now that we have our bounds, now we just binary search. So, and we'll have a result. So let's say our result will start out as the right value, because like obviously if we pick the biggest day, that will always work, assuming we have enough flowers. So let's write their binary search. And this is a template I like to use. So if you like this one, there's other ones, but I prefer this one. There's ones without a result variable. I just think this one's a little bit cleaner, even though it has like another variable. Who cares? So pivot. I guess we do have to worry about overflow in Java. So normally I would do like left plus right over 2. Here I probably want to do something else. I want to do like left plus, I think this is like right minus left over 2 is what I want. Let's see if that works. I believe that's what we want though. I think. Okay. So anyway, yeah, like if left is 2 and right is 5, we'll add 1, which is what we want. Yeah, I think that's fine. So that avoids overflow for sure. And then we just check. So if can make bouquets of a bloom day M and K and P, then we'll make our result equal to that guy. And so if this day works, we'll try smaller days. So this is P minus 1. And if we can't, then we'll try bigger days like this. So like I said, this is the template I prefer. We'll go through all the numbers and we don't have to worry about like missing a day or anything. You can do left as less than right and some other stuff, but it's a lot easier to make mistakes doing it this way. So I prefer this one. Probably will make mistakes doing it this way now that I said that, but let's see what happens. Okay. Okay. So M and K is some big number. Huh. So I don't think we're getting an overflow here, that's for sure. How long is this bloom day? Let's log some stuff. Length and maybe M and K. Well, they shouldn't be bigger. So, okay, well that's a problem. So this is the problem we have. So we're getting an overflow. So I guess what we need is to turn it into a long. We'll probably solve the issue. Yeah. Okay. Let's see. All right. Okay, so there we go. And it's pretty good. Yeah, so the issue was M and K were too big, and then when you multiply them, they were getting an overflow. And that happens a lot. So when you get an error with these like values being too big or too small, it's usually just an overflow. Okay, so time here. So we are going through the log of the day, which is this bloom day. So let's call that M. So that's going to be log. And then N is the length of the array. So for every day, we're going through the whole array. And that's correct. And then did we have any space? Let's see. I don't think so, right? So we just have like an left and a right, which are integer values, pivot integer value, and we're just storing some values here. So these binary searches can be tricky to think of, but generally think of like the way my thought process was going for this problem was like, is there any way I can like go through the array and figure out how to make groups based on the day? And that didn't seem very intuitive because there's just so many combinations you can have, like hard to say, like what day do you pick when there's a bunch of groups? But then you can realize, oh, they all bloom at some day, which every day after that works, and every day before that might work or not. So that's the pattern you see. So like if your solution is solved at some value and it's always solved at every value after that, and then if it's not solved at that value, it's not solved at all the values before then, you can keep cutting it in half. That's the way to go. And usually these binary search problems, basically it's just like not super intuitive to use binary search, and the very hard problems will use a binary search combined with other things. So you can like usually get rid of a dimension essentially using a binary search, because using log on like a big number makes it very small. So that's basically getting rid of a dimension. Yeah, it's gonna be all for this one though. Hopefully you liked it. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.